Number 9 from the BAT list is number 39 from page 226, and the directions on the page are pretty close to what I'm going to ask you on the test, but I'm going to do this problem with you in the same format that the question on the test will be asked. Number 9 says to start with part A by finding your x and y intercepts. Well, remember, when you want the x-intercept, that means that y is 0. Well, for y to be 0, the top has to be 0, which in this case we have 2 on top, so we don't have any. Y is never 0, means we have no x-intercepts. And then for our y-intercepts, that just means that x is 0, so we substitute x into our function to find them. So we do, we don't want h of x, we want h of 0, so everything in the bottom with an x becomes 0, so 2x squared is 0, x is 0, and the minus 3 doesn't go away, and you notice the only thing left on, well, the 2 didn't change, but on the bottom the only thing left is the negative 3. So that is our x-intercept, our y-intercept. So that happens at y equals negative 2/3. And then for part B, we are to factor the denominator, which you should do even without being prompted, but I put that in there just so you won't forget. So we're going to factor the denominator, and we'll start with a 2x in the first spot of each, and the 3 is minus, so there's a plus and a minus, and we need the factor pair, because remember if there's a coefficient other than 1 at the beginning, you multiply it with your constant, so we need the factors of 6 that subtract to give me negative 1, which obviously would be 3 negative and 2 positive. Can't take anything out of the second factor, but we can get rid of that 2 we brought in on the first one. So there's my factorization. So it's x plus 1, 2x minus 3. And we're on part C going to find our vertical asymptotes and our horizontal asymptotes, but let's do the horizontal first. Remember, that's just a top-heavy, bottom-heavy matching test, and for this function it's clearly bottom-heavy, so we're going to have y equals 0 as our horizontal asymptote. Remember, that is also known as the x-axis. Our vertical asymptotes occur wherever the denominator equals 0, which is why you want it in factored form so you can look at it, and that happens for this function when x equals negative 1 or x equals 3/2. Again, you always want to write your vertical and horizontal asymptotes as equations of lines. And then for D, we're going to graph it. So let's grab a straight line here. Meant to already have these waiting for us and forgot to do it on this one. So let's give ourselves lots of room here. So we'll put our y-axis here and our x-axis all the way across and fill in what we know. Let me switch colors to get the graph on here so that it doesn't all blend in with my axes. We'll go to green for the function itself. So let's start back at the beginning. We had no x-intercepts, but we do have a y-intercept at negative 2/3, so that happens somewhere along in here. So there's my y-intercept. We then discovered that our horizontal asymptote is the x-axis, sitting here in the middle. And our vertical asymptotes, we have 2. One is at negative 1, so we'll put that on here. Let's see if I can get a little closer here. There we go. Wait, why am I doing that? Let's use the straight edge tool. Let's get a green bar to represent our asymptote. And it's going to be right there. And we'll continue on down, of course. Oh, that's terrible. Let's try it again. There we go. And then I need another vertical asymptote. I'm sorry, not a horizontal. A vertical asymptote also at 3/2, which would be halfway between the 1 and 2 marks. So I'm going to put that right here. Let me start a little higher. and that's not close to center. Let's try. This is hard to do with a stylus. Clearly hard to do because there I overshot it in the other direction. One more time. Nope, not one more time. Bear with me. I'm going to get this right if it kills me. And that's going to have to be close enough because that's the best I can do. Alright, so it's over in this vicinity. So the horizontal asymptote lays right on top of that last one. And this thing's suddenly not wanting to cooperate with me. So I'll go back and do that with a green pen. My horizontal asymptote is here. And I'm making it intentionally a little sloppy so you can see it on top of that nice straight axis there. So those are my asymptotes. Alright, so let's work on the outsides first because that's generally easier. Since my vertical asymptote was at 3/2, which would be 1.5, I'm going to go to 2 and plug that into the factored form of my function, which would be 2 on top. And then if I put a 2 in the x plus 1 factor, that would be 3. And if I put a 2 in the other factor, that would be 2 times 2, which is 4 minus 3, which is 1. So this would be at 2/3, which tells me that this piece of the graph over here and this side, and that's positive, and we have no x-intercepts, means that this has to be completely above the x-axis on this side. Then we will then go to the left of -1. So let's go to -2. Again, 2 stays 2 on the top. But then when I put a -2 in the denominator, -2 into x plus 1 gives me -1. And then -2 into 2x minus 3 would be 2 times -2 is -4, minus 3 is -7. Well, this is 2 over a negative times a negative, so that's 2 over positive 7, so it's going to be also positive. So this side 2 will come in here like this. This is not a really good, I'm not doing a really good job. You could actually plot these points. But I'm just trying to help you see the gist of what this graph looks like. And this is getting kind of hard in this small detail on this graph. And then we have to get that piece in the middle. Well, remember, we have a y-intercept, but no x-intercepts. And since I have asymptotes on both sides of this point at the y-axis, it's going to have to come down and hug that side, and it's going to have to come down and hug this side. So that gives us a final copy of our sketch. And you would want to go to the ends of the graph all the way down. On to number 10, the last item from our BAT list, which is 4 minus 3x over x minus 5. So this one's a little harder, but on the test, good news, I did this step for you. But what we're doing here is we're going to have to do some long division so that we can see it in transformed form before we answer all these questions. And we accomplish that with long division. So I divide x minus 5 into negative 3x plus 4. And we're going to distribute a negative 3, and we get negative 3x plus 15. And we subtract, and these go away, and then we have 4 minus 15 would be negative 11. And that gives us negative 3 minus 11 over x minus 5. And in case you're wondering, this one probably looks familiar because it's the same function we used on a previous problem. But now I can see all the transformations that have taken place from the parent function, which is one of the questions this problem asks you. So we'll start with the negative 3, or the minus 3, however you want to look at it. And that is outside the function, so that's going to make the parent graph go down 3. Then we have the minus 5 inside the function, so that's inside, it's backwards. It's going to make the parent function go to the right 5. And then we have a negative 11 multiplier on our function, which flips and stretches vertically. So we'll write it flips vertically and stretch by 11 of the parent graph. And then we sketch. So we'll use our sketch to get our domain and range. I don't think the last one asked us for domain and range, did it? It actually did, and I left that off. So I'll go back and add that after we do this one. Alright, so for my graph, let's get coordinate plane here to work with. Try to go as far over here to the side as I can, so we got plenty of room to record our domain and range. And so we will have the y-axis here, x-axis here, and then we'll put our asymptotes in a different color. So let's switch to pink for our asymptotes. So our vertical asymptote, the only one we have, will be at positive 5, because that's our right 5, which will be here. Our horizontal asymptote is at negative 3, which will be here. So that's going to move the parent graph, and again we'll put the parent graph on here for reference, in yellow, which would be up here somewhere. And then would be in this quadrant about here. Remember, you want to hug the asymptotes but not touch them. And so now we have to account for our transformations. So we will begin with the asymptotes took care of the slide left and, right and down. So all we have to do is realize that we're flipping upside down. So we would go 1 to the right of our asymptote, which would be at 6 when we go one step to the right of the 5. And if we plug that into our function, we would have 4 minus 3 times 6 would be 18. So we have negative 14 on the top, and 4 minus 1 would be negative 1 on the bottom. So we'd be at negative 14, which is way down here. So if I extend my asymptote so you see where we're coming from, this would be down in here. And you can get the specific spot by going to the right and down, actually going 14, but we don't really have the space to do that here. And then to get where the other piece is, which is going to be in the upper left area, we go to the left one, which would be 4, so that will be 4 minus 12, which is negative 8, over negative 1, so positive 8. So we'll go up 8 from our green x-axis. 1, 2, 3, 4, 5, 6, 7, 8. It actually runs me off the graph. So that's going to come from way up here, and then come down and hug the asymptote all the way out. And that's where your graph should end up. Then our domain and range, we can look at our picture and decide, and remember we're looking at the pink graph itself, and wait a minute, I just realized I screwed that up. I got crossed up in all my colors. Let's fix that last piece of the graph there. Glad I caught that before I stopped the record and had to redo the whole tape. There we go. That's what it should look like. Alright, so the domain, from negative infinity to, remember domain x rangey, so you just look at x for domain. We have our x restriction at 5, so 5 union 5 to infinity. And then our range, we start at negative infinity, so we're coming from the bottom up using the same approach we did for our domain, but just looking at y's. And when I go up until I get to negative 3 union negative 3 to infinity. Let's run back over to our previous problem and look at the domain and range for this guy. Okay, so the domain, again, is what happens with x. So it goes from negative infinity to, our first hiccup here was at negative 1. So that's union, negative 1 to 3 halves, which was our other 0, union 3 halves to infinity. And then the range, we're only looking at the y's, come from the bottom up, negative infinity to, first place we have a stop in our y values, and we'll just use our y-intercept of negative 2/3 there as our upper point. If you graphed it, it may actually be a little higher, maybe a slightly different point, but I'm okay with doing that with this picture. And then union, and notice it doesn't start right over on the other side, it starts over on the other side of the x-axis. So that's going to be union infinity to 0. And that is the range and domain for this graph, a little belated. And that's the end of our bat list.